Okay. So A over here is going to represent the gradient. So if I have drawn T versus square root of L, if I want to find the value of A, would you agree that I need to find the gradient first? So gradient using this graph can be found easily. All I need to do is I need to pick up 2 points. Okay, let's say if this point would work for me, this is 6 comma 1.2
Yeah.
and that's 0 comma 0. So if I take out the gradient, which is y2 minus y1 over x2 minus x1, 1.2 minus 6, okay,
Okay.
divided by 6. No, 1.2 minus 0 divided by 6 minus 0. So 1.2 divided by 6, what is it coming out? What is 1.2 divided by 6? 0.2.
1.5, yeah, 0.2.
Okay, so it means that the gradient is 0.2. If the
Okay.
gradient is 0.2, so would you agree that A value is also 0.2? So the
Yeah.
equation would becomes time period is always equals to 0.2 times square root of length. That's the
Okay.
relationship between the two quantities that were examining that we had. So that's the equation or the relation that links the length with the time. So if you're being asked how is the length of the pendulum related to the time period, that is how it is. Time period is equal to 0.2 times square root of L. That's how experimentally the equations are derived, and then you are given the equation to solve. Okay.
Okay.
Any questions till here?
No, sir.
Okay, then we see this question now. Y equals to ax plus b upon x. Now we know that this is not the equation of a straight line. If if I have several coordinates of x and several points corresponding values of y, and if I'm going to plot this, I'm not going to get a straight line.
Yeah.
Because right now, if the quantity is x and y, they are not going to give me the straight line. So I need to
Okay.
rearrange this equation. This is a non-linear equation
Yeah.
which needs to be linearized to get in this form, and this is how you are going to do that. So y equals to ax plus b upon x. You are going to take the common denominator, that is plus b. Okay,
Okay.
then you're going to multiply x with over there, so xy equals to ax square plus b. Please make sure that you have to bring this in this form, y equals to mx plus c form, where c is a constant number that must not have any x and y's.
Yeah.
Okay, now
Okay.
what are the quantities that needs to be plotted? So if you see over here, if you are going to plot xy against x square, you are going to get a straight line. If xy becomes your capital Y, a becomes your gradient,
Yeah.
x square becomes your capital X, and b is going to be your y-intercept. So this simply means that if you would have plotted xy values against x square, okay, you would get a straight line. You would get a linear line.
Sir, can you repeat
That's
this
the
part?
thing. I'm trying to say that if you plot xy
Yeah.
against x square, then you are going to expect a straight line. Otherwise, if you plotted against x, you will not get a straight line because that was a non-linear form. We have to linearize this, and this is how you linearize it. You multiply or divide, rearrange the equation in such a way that your non-linear equation is represented in y equals to mx plus c form. So now if I have x and y values, I'm going to multiply and get x y values together. These are going to give me different set of values now, and they
Okay.
need to be plotted against x square. So this is what's going to happen. You don't need to show this as a working, but but I'm just telling you that if you have x and y values initially,
Yeah.
plotting x and y will not give you a straight line. Now the question was, what should be plotted against what to give you a straight line?
Yeah.
Okay, so by rearranging our equation, we now know that if we plot x square against xy, then we can get the straight line. So we
Okay.
have, let's say, x, whatever values of x is, we are going to take the x square value. Okay, x key value, we are going to find the x square. We have y value, we are going to multiply y and x to get xy. So
Okay.
this is how you are going to fill in the table, and using these points, you are going to draw the graph, and you are always going to get a straight line.
Okay.
Okay.
Sir, in linear, doesn't like the power of x, like it can't be above 1?
Yeah, you're right. I'm not saying the equation is linear. See,
Okay.
what happens is, okay, over here we are plotting two quantities on the x and the y axis. We call an equation to be linear when it gives us a straight line.
Yeah.
And when I plot y versus x in this equation, obviously it won't give me a straight line. It is a
Yeah.
non-linear equation. It is going to result in some sort of curve.
Yeah.
But if I want a straight line, I want to make sure which two quantities are plotted against each other.
Yeah.
So rearranging the equation just tells me that if I plot xy against x square, now over here I'm getting x square values. Now it's up to you. You can name this x square as capital X, and you can name this xy as your capital Y. So if I rewrite this equation for you, that is going to be y equals to a. Now a could be any number, right? Let's say
Yeah.
a, x square can be written as x plus whatever the y-intercept is. So now if I am looking at this equation, what is the power of x?
Oh, it's
It's
1.
1.
Oh, okay.
Then
Okay.
done till here.
Yeah.
Okay, now let's try this question. Convert y equals to a e to the power of minus bx. Now this will involve logs as well, because we have exponential equations. In order to linearize it, we might need logs to solve this. So the
Okay.
equation is y equals to a e to the power of minus bx. What is the first step that comes to your mind?
Mm. So will you do y divided by a so you can bring in ln?
You can still bring ln over here. You can bring ln over here, ln over here. That's still possible.
Okay.
Now, if you have ln of two numbers being multiplied, what did the product rule says?
So ln a plus ln e to the power minus bx.
Ln a plus ln e to the power minus bx equals to ln y. Now, please remember that you need to rearrange this in this form, y equals to mx plus c form.
Yeah.
So, how do you plan on rearranging? What can you do about this power?
So you can bring it in front.
You can bring it in front. So that is going to give you minus bx times ln e. What is ln e?
1.
Ln e is 1. So I'm going to write minus bx over here and ln a over here. Ln a term is independent of x and y, and this is minus bx. So if you pay attention over here, you are going to realize that this is your capital Y and this can be your capital X. So this value of minus b will result in gradient, and this value of ln a is going to be your y-intercept.
Okay.
Okay.
Yeah.
So if I would have the graph, and using that graph, okay, for example, uh, if I have a graph of ln y, versus x. If I plot ln y against x, I'm going to get a straight line. Okay. So if
Okay.
I have 2 points, if the question has given you 2 points on the graph, and if you find the gradient using these 2 points, you are basically finding the value of minus b. So for example, let's say the value of the gradient, for example, the gradient comes out to be minus 2. So m is minus 2. And what is m representing in the equation? Minus b.
Yeah.
So that is equal to minus b. Therefore, the value of b is going to be 2. Okay. And for example, if you would have given the graph, or you would have been told that the graph intersect the y-axis at any particular value. Okay. Now, let's say the y-intercept is 3. So ln A is going to be equal to 3. So how would you find A key value?
Um,
So ln A is equal to 3. So A is going to be equal to
like 3 upon ln, but
ln is always to the base E.
oh sorry. So e to the base 3 equals to a.
So A is going to be equal to E to the power of 3.
Yeah.
Okay. So
Yeah.
that's how you do this.
Okay.
If you were asked to find the values of A and B, right now you're just being asked to represent this in this form. So Y, capital Y is ln Y, capital X is X, the M
Yeah.
value is equal to minus B, and C value is equal to ln A. That's it.
Okay.
Okay. Okay, you may try one on your own.
Okay. I have to convert this into linear form, right?
Yes.
Okay. Sir, so would it be like y is x under root upon y, and x would be a under root x?
Yeah, just give me a minute. I need to attend a call. Okay.
Okay.
Yeah. So if you are going to solve this, you're going to get a root x minus b. You multiply root x over there. So this is your capital Y,
Yeah.
and that can be your capital X. This is going to be your gradient, and that's your y-intercept. Is that correct?
Yeah.
Okay, great. Now, converting from a linear form to a non-linear form. So right now you have been given a straight line and the two coordinates are marked over here. But if you see the axis, y is plotted against x square. Okay. So
Yeah.
first thing first, I am going to find the equation of this line.
Okay.
Okay. So capital Y equals to m capital X plus c. That's how you are going to start.
Okay.
You're going to find the gradient first.
Yeah.
So gradient is going to be 8 minus 4 divided by 6 minus 0. So 4 over 6, which is 2 over 3.
Yeah.
And for the value of c, you can clearly see that it intersects at 4. So y equals to 2 upon 3x plus 4. Okay.
Yeah.
Now you can replace y and capital X with the quantities that were plotted. So capital Y is simply going to be small y, 2 upon 3. Capital X was x square plus
Oh,
4. That's your non-linear equation.
okay.
Okay, get the point. Now
Yeah.
try
Yeah.
the second part on your own.
Will it be xy equals to minus x?
Let's check. First of all, you are going to find the gradient, which is going to be a negative 1. 2 minus 7 over 6 minus 1 minus 5 over 4 is your gradient. So capital Y equals to m capital X plus c. The gradient comes out to be negative minus 5 upon 4 capital X plus c. For the value of c, now I cannot read the y-intercept, so I will have to use the knowledge of the y-intercept. If I want to find the point on the y-axis, I have to take x as 0.
Yeah.
So minus 5
Sir,
over 4
writing
times
something?
0. Sorry?
Are you writing something?
Yeah.
No, I think the screen's frozen. That's why.
Okay. Just hold on a second.
Okay.
How about now?
Yeah, no, it's fine.
Okay. So what you are going to do right now is you're just going to plug in any point when x is 1, y is 7. So you can find the y-intercept, that is going to be 7 plus 5 upon 4, which is,
Sir, for the gradient, it would be 6 minus 1, right? For the x values. So it's coming to
it's
minus.
going to be 5. Yeah, my bad, sorry. That's going to be 5. So, so is the gradient minus 1?
Yeah.
Okay. Now for the y-intercept, you can use any point. Let's say if I use this point, so y
Yeah.
is 2 when x is 6. So c comes out to be 8.
Okay.
So capital Y equals to m which is minus 1, x plus 8. Now you can replace capital Y and capital X. Capital Y is going to be replaced with xy.
Yeah.
Capital X is going to be replaced with x, and that's your nonlinear equation.
Okay.
Okay. You can
Yeah.
also write this equation in this form: minus x plus 8 upon x. So that is going to be y equals to minus 1 plus 8 upon x.
Okay.
All right.
Yeah.
Let me know when you're done. Okay, let me know when you're done.
Okay. Yeah, I'm done.
Okay, try this one out.
Okay.
Yeah, did you understand the question?
Yes, I'm just doing the last part. Sir, is B equal to 100 and A equal to 10 to the power minus 7?
Let me solve it and then we can confirm. So variable x and y asserted y is equal to 8 times b to the power of x, where a and b are constants. The diagram shows a graph of LGY against
Okay.
x. So that's your capital Y LGY.
Okay.
We are going to first of all find the gradient, which is going to be 13 minus 5 divided by 6 minus 2. Is the gradient coming out to be 2?
Yeah.
Now this coordinate 2 comma 5 is the coordinate for capital Y and capital X.
Okay.
So C comes out to be 1. Yeah.
Okay. I
So
made a
this means,
mistake. I took one coordinate from this and then from the ending point.
okay. So LGY is going to be equal to 2 times X plus 1. That's the equation. LGY equals to 2X plus 1. Yeah. Now
Sir,
what do
can you
we,
repeat the equation part again?
the equation part again?
Yeah.
Okay. Are you clear till here that C is 1?
Yeah.
So this means if I rewrite this equation, capital Y equals to gradient M, capital X plus C, and the y-intercept comes out to be 1. Okay.
Okay. Okay. Yeah.
So now I'm going to replace Y with LGY and X with small x. So the equation becomes LGY equals to 2x plus 1.
Okay.
I need to solve this equation and represent this in this form. So basically I want to make y the subject. So LG is always to the base 10. So if I convert this into from a log form into an index form, that is going to be 10 to the power of 2x plus 1.
Yeah.
Okay, so if I now I have to split it up, 10 to the power of 2x times 10 to the power of 1, right?
Yeah. Yeah.
So y equals to 10 to the power of 1 times 10 to the power of 2x. Remember that I need to express in the form of y equals to a b to the power of x. So I need a constant term which is over here, but I need b to the power of x, not 2x. So I need to solve this further. 10, I can write this as 10 squared to the power of x, which is going to be 10 times 100 to the power of x. Okay,
Okay. Yeah.
so a is going to be 10 and b is going to be 100.
Okay.
All right, let me know when you're done.
Okay. Yeah, sir, I'm done.
Okay, now in this, do you have your graph paper with you?
Yeah, I have it.
Yeah. Okay, so We have been given x and y key values. So, and this table shows experimental values of variable x and y. Part A says by plotting suitable straight line graph, show that x and y are related by the equation y equals to k times x to the power of n, where k and n are constant. First thing first, we need to know, okay, what is the equation of the line?
Okay.
So we need to plot a suitable straight line. We know that if we just plot y and x, we are going to get a curve. We are not going to get a line. So we
Okay.
need to apply linear law over here. And using this equation, y equals to k times x to the power of n. Now you need to come up with a right strategy to convert this non-linear equation into a linear form. What should
Okay.
be done? What is the first step that comes to your mind?
You can take LG, I think.
Yes, you are going to apply logs on both sides.
Okay.
So on the right, would you agree that this is going to be lgk plus
Yeah.
lgx to the power of n?
Yeah.
And this power of n is going to come down, and this can be written as n lgx plus lgk equals
Yeah.
to lgy.
Yeah.
Now you can call this as a gradient and this as a y-intercept. This does not involve any x and y.
Okay.
So my capital X would be lgy.
Okay.
This is going to be the gradient.
Great.
Lgx is going to be my capital X, and this is going to be my y-intercept.
Yeah.
So what are the two things that are going to be plotted against each other? Lgy
And Y.
against
And
lgx. So now, before drawing a straight line, you need to come up with a table that will have the values of lgy and lgx.
okay.
So lgx, lgy. So you use your calculator to, you have the value of x is 5. So what is lg5 gonna be?
0.69.
0.699.
Yeah.
lg10, it's 1. So
Yeah.
1.03. lg20,
1.3.
1.301.
Yeah.
Then lg40,
1.602.
2. Okay. lg80,
1.903.
1.903. Now can you find lgy? इसी
Yeah.
तरीके से
The first one's 3.414.
3.414.
Yeah.
Then
Then 3.203.
3.203.
2.992.
992. I'm getting 3.
Yeah, there's a 5 after it.
Then
2.782.
2.782.
And 2.571.
Okay, great. So you have these values. Now you are required to plot it. So the lowest value can be 0 on the x, okay? You're going to plot lgy. These are lgy values and these are lgx.
Okay.
Now you need to take your scale in a suitable way such that the graph is not too big and not too small. Okay. The
Okay.
maximum you can go up till the x values is till 2.
Okay. So for y, should I take 3 centimeters per unit?
For y, you can take one big box to represent 1 centimeter. I mean, I don't know what type of graph paper do you have, so you can take
I'm
it.
using centimeter one.
Okay. So this is going to be LGX and LGY. So the first value comes at 0.6. Okay, so what I'm going to do is I'm going to call this as 0.5, 1, 1.5, and 2. Okay, that would
Okay.
do. And for Y, I I must only go till 4, I think. So that's 1,
Yeah.
2, 3, and 4. The first value is 0.699 till 3.414. So 0.6 is going to be over here, and it's 0.699, that is roughly 0.7, 3.414, 3.4. That's one of the value.
Okay.
Okay, so these are the points you have to draw a suitable straight line.
Okay.
Something like this. So if you remember, the equation was LGY equals to NLGX plus LGK.
Yeah.
So if I want to find the value of N and LGK, for LGK, one thing is that I can just read off the graph. if that's possible. And
Oh,
for n, I'll find the gradient. So for gradient, I can take any two values on the graph. So that is going to be, let me take this value and this value. So n represent the gradient, which is going to be 0.5 comma 3.5, 2 comma 2.5. So 2.5 minus 3.5 divided by 2 minus 0.5. So yeah, that's what I am getting. You should get close to these values. Your values might not be exact, coming out to be same as mine.
okay.
So I'm getting minus 0.6667. So if I want to round it up to one decimal place, I'm going to round it up to negative 0.7. Okay.
Okay.
And this value is somewhere around the y-intercept, which is LGK, that is somewhere around 3.9.
Okay.
Okay, so if I want to find the value of k, I'm going to take 10 to the power of 3.9.
Okay. Yeah.
So what is 10 to the power of 3.9?
7943.23.
So 7943.
Yeah.
Make sense? This is how
Yeah.
you're going to find the values of n and k.
Oh,
Any questions?
no, sir. Understood.
Okay. I want you to take a screenshot of this
Okay.
and try this on your own, and then we can discuss in the next class. Okay.
Yeah, I've taken a picture.
Okay. See you in the next class then.
Okay. Thank you, sir.
You're welcome. Bye bye.